Hello, this is a first of two recordings I'm going to make discussing exploratory data analysis, in which we'll focus on the use of the JUMP software. And I also want to point out I'm not going to discuss every detail. You really need to work through these sections using the data provided. Most of it will be from the JUMP sample data directory in the help menu. And I recommend, even though I'll show you some things, try them yourself because there are many ways to explore and visualize data in JUMP. And these platforms that I'm going to show you are quite powerful, and it's better that you explore them yourself. And I wanted to mention the idea of exploratory data analysis versus what we call confirmatory. These particular slides I also use in a course I teach on what's called Six Sigma for continuous improvement, and in which we go through what they call the DMAIC cycle. So for those of you who are familiar with the Six Sigma course, you'll realize what DMAIC means. It's not important to everyone, but the concept of what we call exploratory data analysis versus confirmatory is important. And EDA, and I've mentioned this before, always precedes more complicated statistical analyses. And as you'll see, a good part of what we call exploratory data analysis is actually visualization. So there'll be a heavy emphasis on visualization in this section. So I'm going to go ahead with slideshow. And again, just keep in mind this idea of EDA versus CDA is important, and unfortunately a lot of training in statistics up until recently almost entirely focused on CDA, which were things like hypothesis testing, confidence intervals, and those things are actually declining in importance. As we have more data and more powerful software, the focus is more and more on visualization and exploration. So, basically, and I mentioned this before, in exploring data, a simple heuristic is to look at variables one at a time, their distributions, two at a time, and three or more at a time. And in the pre-processing section, which we've covered, we more or less did the same thing. So I won't repeat everything that's in the pre-processing section, because pre-processing, frankly, also involves visualization and exploration. But in pre-processing, most of that exploration is towards finding problems in data and trying to correct them if possible. So we're going to look at a number of different platforms. I won't necessarily cover every one of these, but I just wanted to kind of familiarize you with some of the main platforms that are used in JUMP for exploration. Okay, so we're going to start with a JUMP sample help data called car physical data. This is just some physical data on various types of cars. So one of the things we might do first is to use the distribution platform to examine the distributions of each variable, or as I showed you in pre-processing in JUMP 12, the new what's called column viewer can also be used. So I'm going to quickly just bring over JUMP and go to Analyze. Well, actually, what I'll do is I'll illustrate the column viewer again. So instead of going to Distribution in the Analyze menu, in the Columns menu, I'll go to the column viewer. And I'm going to, let's see, I'm going to specify I'm going to skip model at this point. Okay, so I'm just going to look at the, we can get this to work. So I'm just going to bring over the variables country through gas tank. Okay, so I want to show the quartiles and I want to show summaries. Okay. So you can see there do not appear to be any missing data. We have two nominal variables, one with 3 levels, one with 5, and I'm just going to show the distributions. So here are the distributions, and again, nothing looks particularly alarming. All of the observations seem to make sense. I don't see obvious outliers. Notice there's one vehicle that's a very high horsepower, but this again doesn't appear to be an outlier. It's just there some of the cars are much higher powered. And also remember, the alphanumeric categories make sense. And in exploration, actually these excuse me, distribution reports are useful. For instance, I can click on USA in one plot, and because of the interactivity of jump, I can look over the other plots and see all of the observations corresponding to USA, or I could click on Japan and so forth. Or I could click on small and I could see all of the small cars that are made, and obviously you can see, yes, they're small, and also you would expect them to have smaller physical measurements such as weight, turning, circle or radius, and so forth. So far this is a quick exploration, and we don't necessarily see any difficulties. Okay. There we go. Also, another useful platform in jump is called Tabulate, and this is particularly if you have a very large data set and some nominal variables. Sometimes a cross-tabulation table, Jump calls them Tabulate, Excel would call them pivot tables, can be useful, and the Tabulate platform in Jump actually is a nice place to create these what I would call cross-tab tables or pivot tables. It's entirely drag and drop. I'm only going to briefly show it to you. So in the Analyze menu, there's a menu called Tabulate. Okay. So maybe by country, I'm interested in summarizing the data, so you get a breakdown of countries. It may be within country, so I bring a point over and I put it just to the left of country. Now we have a breakdown by country and car type. And then maybe instead of, say, just the number of observations, I'm interested in some other variable. So I'm going to drag displacement over to the column drop zone. And what I get is column placement, the sum. Maybe rather than that, I would like to look at the mean, so I can drag the mean over. So now I get the sum, the mean. Okay. And by the way, you can delete columns if you want to. It's quite easy to use. I'm not going to spend too much time on this. I think it's very straightforward how it works. And I might be interested in the max, so I bring max over and create a column for the max. And you can also, there's a place to change format if you want to. You can also have another set of options under the report menu. You can show a graphical display, and you can make this into a data table, essentially a pivot table. And again, particularly if you have a lot of data, summarizing the data for further analyses might actually be a good idea. And finally, while I'm here, I'll show you one other way you can summarize data. It's pretty quick, and you go to the Tables menu where you operate on a table. There's a summary option. So just to quickly show you how summary works, okay. Let's see. I will just, let's see. There we go. Cancel. Okay, so maybe by I'm going to do it the other way around. By country and type, I want to look at the average turning radius or turn circle. So I would select mean, and that's another quick way to summarize data. Okay, very straightforward to use. Okay, so I'm going to skip through some of this. Graph Builder is basically what is becoming the graphing platform in Jump. It's very versatile. We've already used it a little bit. So basically, for instance, if I use the car physical data, if I go to the graph menu, Graph Builder is right at the top. They're telling you they prefer Graph Builder. So I might do something like by country, I would like to look at weight versus horsepower. Okay. And of course you expect there is a relationship, and I could even break this down further by type, but you simply get the idea of how it actually works. Okay. And again, if I were to drag type over, notice we get a breakdown. And by the way, for large, other, there's only one vehicle, and that's the Volkswagen Vanagon. I'll come back to a Graph Builder, but there's no limit to the things you can create in here. It gives you lots and lots of options. The only way to really gain experience with it is to just simply try it. And also I'll mention, if you have an iPad or an iPhone, the Graph Builder app is a free download on iTunes. It won't run all of Jump, but you can actually work with Graph Builder on those devices and do actually quite a bit of visual analysis. Okay, so just go ahead, and as I said, I'm not going to go through everything you can do in these slides. Okay, actually I think I will show you one other one right now, and that is mapping in Graph Builder. Okay, so I'm going to bring Jump back. And I'm going to close out the car physical data. Okay. And from Jump Sample Data, under the Help menu, okay, I'm going to bring up another data set called SAT by year. And I'll use this to illustrate mapping. Okay. There we go. Okay. So this is data on SAT scores and a number of other variables, and this is by state, year, and again there's data, lots of data. Notice there are latitude and longitude, which can allow you to create a map. I'll show you a couple of ways to do that. And also there's a variable called state, and it turns out Jump has a lot of native mapping files and shape files that are related to keywords. So something like state, if you put it in the right place in Graph Builder, will trigger a map. So I'm going to go to Graph Builder. Notice this is map shape. So I'm going to drag map down. Notice suddenly we have a map, and that's because there is a mapping file that Jump recognizes by the keyword state and triggers a map. And at this point you could drag over things like SAT math. I'll drag it onto the map, and essentially what you get is a heat map based on states, and you suddenly discover that Iowa, North Dakota, not Montana, Minnesota all do really well, where states like Georgia, South Carolina don't do so well, and New England doesn't seem to do so well. Well, I'm going to show you in a little bit this is actually very misleading, and I wouldn't jump to conclusions, but I did want to show you the other way to create a map. So I'm going to start over, and I have the by the way, JUMP recognizes the data type latitude and longitude, so it understands geographic coordinates. So I'm going to drag latitude over to Y and longitude to X. Okay. Put the cursor right in the middle of the table, right click where it says graph in the drop down menu, go to background map. And I typically just use OpenStreetMap. It's really wonderful and open source. And on the other side, I would like to show US states. Okay, so I'm going to now create the map. And by the way, you can create all kinds of other maps or use your own map files and so forth. You can even create them. On the JUMP file exchange server, there are some JUMP add-ins that will help you show you how to create map files and how to create your own. Okay, so this is a map. Again, you can do things like drag over a variable, okay, and try to measure. Let's see, what do I want to drag over here? It's a good question. I want to color by, where did I go? Here we go. Okay. So it'll create a map. Also, if you go to the ribbon at the top of any report window, this little blue ribbon, there's a magnifier, so I can come down if I want to and blow the map up, increase it. Okay. Notice, by the way, since this is OpenStreetMap, it can actually take it right down to the street level. That has no relevance here, but there are other data sets where you have data right down to street location and you're given longitude and latitude. You can actually track things like crime in cities right down to the street level of where these crimes may be happening, and I don't think it's a stretch for you to realize that that actually is in active use in a lot of communities, that capability. I'm going to start over, and I'm going to go back and reconstruct the original map. Again, I'll drag state down to map shape, and I'll drag over, again, I'll just drag over SAT verbal. Now I've created a heat map based on states. But there's some other variables in here that might be of interest, like region. So maybe I'd like to filter the map by region. JUMP has what I would call on-the-fly data filters. In the main data table under the rows menu, there's what's called a universal data filter, and it will apply filtering to every open spreadsheet that's relevant and any open graphic. More often than not, we'd really like to filter down at the platform or report window stage. So you would go to the main report menu, in this case Graph Builder, and it's located in the script menu. I'm not sure why, but it is. And virtually every platform in JUMP has a local data filter stored under the script menu. This allows you to locally filter data. So I'm going to click on local data filter. Okay. And then I'm going to pick a variable, and I'm going to pick region. Okay. So I'm looking at my map, and suppose I only want to focus on New England. I just click on New England. And by the way, isn't that great? New Hampshire leads the way. Since red means high heat. Okay, and I can go to the southwest. okay, where Utah's leading the way, the Plains, and so forth. Oh, Nebraska, the Cornhuskers are doing really well. It must be and they're red colored as they should be. If you're a sports fan, that'll make sense to you. But notice how nicely this data filter works, and that you can do all kinds of filtering. Okay, I could clear this and I could start over. Maybe I want to filter by year. Okay. So I click on a year and the map adjusts to the year. Okay. It's literally filtering the data on the fly and so forth. Okay, so that's what we call data filtering. And this is all explained in the notes, so I'm going to skip through some of them so you can see it. And again, you can do universal data filtering right from the main data table. The data filter is in the rows menu. Scatterplot matrices. Remember we said the idea of examining variables two at a time? Well, I've probably illustrated this in the past, but I'll just quickly illustrate again. And what I will do is go to the graph menu. I'll just use a data set I have that's open. So I go to the graph menu, Scatterplot matrix. This is a great way to examine data two at a time. So I'll just pick some variables that make sense. I won't drag them all over, but I'll drag them over. Okay. Take a look at them, and from the scatter plot, basically what we're doing is we're quickly looking for relationships. Notice there are some interesting variables. For example, California has an unusually high student-faculty ratio. If you look in some of the maps, Texas has a relatively high expenditure versus population and so forth. Okay. So you can see some things are closely related, like percent taking in 2004 versus 1997, meaning it's still pretty consistent in terms of how many people take the SAT that are eligible in each state. And we see a relationship between expenditures and salary. Well, that's not surprising. Okay. And just looking at these, we can spot outliers and we can spot potential relationships. So Scatterplot matrix, very easy to use. It's probably one of the first places you want to start if you want to examine variables two at a time. Okay. And I'm going to skip through some of this. Okay. What this is showing you is how you can stratify a scatter plot. Basically, all you do, put the cursor on the plot, right-click, and pick row legend, and then pick the variable you want to stratify by. So in this case, we want to stratify our physical card data by country. It's very, very easy to do. You can do 3D plots, and then bubble plots are really interesting. This is a way to add additional degrees of freedom to a plot. So I'm going to go ahead and show this in jump. So we'll bring jump over, and we'll continue on using this SAT data. So I will go to the graph menu, select bubble plot. The way bubble plots appear to have originally been developed by meteorologists as a way to put more degrees of freedom on a two-dimensional plot. So I'm going to use, let's see, SAT verbal as Y, SAT math as X, okay, and let's see, percent taking 97 as a sizing variable. So you're going to plot circles, or in 3 dimensions they'd be bubbles, and the diameter of the bubble will be determined by another variable. And I want to do time by year, and I want to ID by state. Okay, you can also use a coloring variable, but I'm not really going to use that right now. So I create the bubble plot, and this actually shows us why the earlier plot where I was showing SAT scores by state, the heat map, is misleading, because notice there is a relationship between SAT math and SAT verbal, but as the scores are getting higher, notice the percent of eligible students taking the test is going down. So notice Iowa has the highest overall SAT scores, the lowest percent taking. So what's going on? Well, the answer is, in those states you saw earlier that were, had the bright red, had the highest SAT scores, those states, most students take the ACT test, which is headquartered in Iowa, and don't take the SATs. So typically only the higher performing high school students who may be heading to the east or west coast where the SAT is used actually take the test. So other states like Massachusetts or New York, a high percentage of students take the SATs, period. Many of them may not be well prepared for college work. So we're really not comparing apples to apples, because the populations taking the test are not necessarily the same in all the states. So it's not really true that all the students in Iowa are well above average and all the students in Georgia are well below average. It's really a function of how many students out of the eligible population actually take the test, and the smaller that percentage, the more likely they're better prepared students. And what I'm going to do now is create a map. And then, not a map, I could put a map on this, I've decided not to. You just right click and put in a background map, but I'm going to do a time plot. And this is interesting because you can create movies, and this is a simple one, but we're seeing how things change over time. And you more or less, though, see the same few states are mostly at the top, and that's because they're less people taking the test. Okay, so that's called a bubble plot, and there are all kinds of uses for them. It adds degrees of freedom to a plot. That's one of the nice things about them. Okay, so go back to jump. And column switcher I will not talk about. You can read about it. Basically what column switcher is, particularly in the graph menu, suppose you wanted to do a scatter plot, but you wanted to go through a whole series of variables, a whole series of scatter plots. Well, if you have a lot of continuous variables, column switcher, again it's in the script submenu of the main report menu, you can take and list a whole set of variables that you would like to see in a scatter plot, and jump will just step through them. Can be useful if you're trying to explore scatter plots for a large number of variables and you'd like to look at them one at a time. Okay. And tree maps, I'm actually not going to look at them. Tree maps are an alternative to mosaic plots, which I discussed when I talked about visualizing nominal variables. Tree map, again, you can read about it. It's in the graph menu. It's just another way of trying to visualize relationships among nominal variables. As I said, I won't discuss everything that's in here. And the last part of this is called the partition platform, and I'm going to make this actually a separate discussion, a short discussion, And later on, we're going to come back to this because this is really the beginning of exploring causal relationships.